Welcome to The Hidden Layer, the show where we decode the future of AI. We're all trying to build bigger and better things with AI, but there's this one huge roadblock. How in the world do you get a whole team of AI agents to build a complex piece of software without it all turning into a complete mess? Well, today, we're going to break down a brilliant new solution from some top researchers, and I'm going to show you exactly how you can use these ideas in your own projects. So picture this. You spin up a team of super smart AI agents. You give them a big, ambitious coding task, and you turn them loose. What happens? Total chaos, right? One agent overwrites another's changes, functions get renamed and break everything. It's a digital traffic jam. If you've ever tried this, you know exactly how frustrating that is. But what if instead of that mess, you had this? A clean, organized, professional workflow. A system where every single agent has its own job, works in its own space, and then merges its work back into the main project without causing a single conflict. This isn't just a dream scenario, it's a real framework that we're about to dive into. All right, let's get right to it. In the next 5 minutes, I'm going to walk you through a framework from researchers at Carnegie Mellon that has been shown to boost AI team performance by more than 26%. And you're definitely going to want to stick around, because a little later, I'll reveal the secret dial that lets you tune this entire system for either maximum speed or absolute rock-solid accuracy. So first, we have to really understand the problem. I like to call it digital spaghetti. It's what happens when you have all these different AI agents poking around in the same codebase at the same time. Without a really good system, they just create this tangled, unmanageable mess. The paper gives this perfect and kind of painful example. Okay, imagine Agent A decides to rename a function, say from calculate to compute. Makes sense. But at the exact same time, Agent B is busy writing some new code that still calls the old function name calculate. You see the problem? When you try to put their work together, boom, the whole thing just breaks. That's the core challenge. Now, the logical next thought is, okay, forget the team. I'll just use one super agent and give it way more time and a bigger budget. Well, the researchers tested that, and the data is crystal clear. That's not the answer. Just look at the red bars here. That's a single agent with double the chances to get it right. The improvement is tiny. Sometimes it even gets worse. So the problem isn't the power of the AI, it's the process. So, if the process is the real problem, where do we find a better one? Well, the solution is actually kind of beautiful in its simplicity. We just need to teach the AI agents to work like human developers. We can literally borrow the battle-tested tools and infrastructure that human software teams have been perfecting for decades. And this table right here, this is basically the Rosetta Stone for this whole idea. It's brilliant. On the left, you see concepts we human developers use every day. And on the right, you see how they're used to coordinate AIs. So a dependency graph becomes a schedule for the agents. A Git work tree, which is like a separate copy of the code, gives each agent its own private office. And things like git commit and git merge become the formal language they use to turn in their homework. It all just clicks. And all of that comes together in this framework. It's called CAID. That stands for Centralized, Asynchronous, Isolated Delegation. Yeah, it's a mouthful, and the diagram looks a little complex, but the idea is simple. You have one manager agent who acts as the boss. It hands out tasks to the engineer agents, they go work in their private spaces, and then they submit their finished, tested code back to the manager for approval. Let's break it down into 4 simple steps. First, the manager plans everything out. Who does what and in what order. Second, each engineer agent gets its task in its own isolated workspace, that Git work tree we talked about. Third, and this is so important, the engineer has to run tests and prove its own code works before it can commit it. And finally, step 4, the manager merges that verified code back in, and the whole cycle starts over again. I really want to hammer this point home, that workspace isolation is the absolute secret sauce here. Giving each agent its own Git work tree is like giving every developer their own soundproof office. It physically prevents them from stepping on each other's toes. This is how you transform that digital spaghetti into clean, parallel development. And the results? Well, they really speak for themselves. This chart is everything. The blue bars show the performance gains from using the CAID team framework. The red bars, that's the lone wolf agent with double the budget. I mean, it's not even a contest. The coordinated team approach just crushes the lone wolf method every single time. So how much better are we talking?
Well, on really hard tasks, like trying to reproduce a whole scientific paper from scratch, the CAID framework delivered a performance gain of over 26%. That is a massive jump in what's possible. And remember, this wasn't achieved with a better AI model, but with a way better process.
Okay, so this is all fascinating research, but let's get down to brass tacks. How can you, as an engineer building things today, actually use this? Let's get into the practical takeaways.
Here it is, your checklist for building a verifiable AI team that actually works. First, you have to plan ahead. Use a manager agent to figure out all the dependencies before anyone starts writing code. Second, and you know I'm going to say it again, isolate those workspaces with Git work tree. Third, integrate work deliberately with Git merge. Now, this next one's a non-negotiable. Demand self-verification. Make your agents run tests and prove their code works. And lastly, talk to them with structure. Use something like JSON for instructions, not ambiguous natural language.
Okay, remember that secret dial I promised you at the beginning? Well, here it is. The research found this really clear trade-off between how fast the team works and how accurate the final result is. And it's all controlled by how strict the manager agent is with its code reviews. This is a super powerful lever you can pull.
So here's the bottom line. You are in control. You get to choose what's more important for your project. Do you need absolutely bulletproof, high-quality code? Okay, then you tell your manager agent to be super strict with its reviews. It'll take a bit longer, but the code will be more robust. Or are you in a rush and need to ship something fast? Just prioritize efficiency. Let the engineers verify their own work, and you'll get results much quicker. The power to find that perfect balance is totally in your hands.
And this all leaves us with a pretty fascinating thought to chew on. We've essentially just taught AI agents to use the best practices of human software development. It really begs the question, what happens next? What happens when these AI managers, with their flawless memory and their tireless ability to analyze dependencies, what happens when they actually get better at managing complex projects than we are?
If this is the kind of stuff that gets your brain buzzing, make sure you subscribe to the Fin Layer for more deep dives into the frameworks that are literally shaping the future. And if you want to get into all the nitty-gritty details, the link to the full research paper we talked about today is right down there in the description. Thanks so much for watching.